Picture a fighter jet that costs less than a luxury sports car, can pull maneuvers that would kill a human pilot, and rolls off the assembly line faster than your Amazon delivery. Welcome to the future of air combat, and it's already here. Before we dive in, take a second to hit that like button. It helps this video reach more curious minds. The Anduril YFQ-44 Fury isn't just another drone. It's a complete paradigm shift in how we think about air superiority. Picture this, a sleek, jet-powered aircraft that looks like it was ripped straight from a science fiction movie, measuring 25 feet long with a wingspan that could fit inside your average suburban garage. But here's where things get interesting. While traditional fighter jets like the F-35 Lightning cost around $85 million per unit and take years to manufacture, the Fury is designed to cost roughly $3 million and can be assembled in a fraction of the time using advanced manufacturing techniques. This isn't some distant concept gathering dust in a research lab. In February 2024, Anduril Industries announced they'd successfully flown the Fury, marking a pivotal moment in military aviation history. The aircraft represents something the defense industry has struggled with for decades, making advanced military capability affordable and scalable. Think of it as the difference between a handcrafted Swiss watch and a precision smartwatch that costs 1/100th of the price but can do 10 times more. The Fury is designed as an autonomous fighter that can operate independently or alongside human-piloted aircraft. It's powered by a single turbofan engine that pushes it to high subsonic speeds, meaning it's fast enough to keep pace with modern fighters, but doesn't break the sound barrier, which helps keep costs down and reduces complexity. The airframe utilizes what's called digital engineering and modular open systems architecture. In plain English, that means the entire aircraft was designed on computers that simulated every possible scenario before a single piece of metal was cut, and its internal systems are built like Lego blocks that can be swapped out or upgraded without redesigning the entire plane. To understand why the Fury matters, we need to rewind the clock and look at how we got here. For the past 70 years, military aviation has been locked in an arms race of complexity. After World War II, fighter jets became increasingly sophisticated, packed with more advanced radar systems, weapons, and avionics. Each generation became more capable, but also exponentially more expensive and time-consuming to produce. The F-35 program, which began in the late 90s, perfectly illustrates this problem. It's arguably the most advanced fighter jet ever created, featuring stealth technology, sensor fusion, and capabilities that would seem like magic to pilots from just a generation ago. But this sophistication came at a staggering price. The program has cost over $1.7 trillion when you factor in development and life cycle costs, making it the most expensive weapons system in human history. Each F-35 requires thousands of hours of specialized labor to build, and training a pilot to fly one takes years and millions of dollars. Now here's the strategic dilemma that military planners have been wrestling with. What happens when you lose an $85 million aircraft in combat? Every loss is catastrophic, not just financially, but in terms of the highly trained pilot inside and the months or years needed to replace that aircraft. This creates something military strategists call exquisite capability paralysis, where your weapons are so valuable and irreplaceable that you become hesitant to actually use them in high-risk situations. Enter the concept of attritable aircraft. The term sounds harsh, but it's actually revolutionary. An attritable drone is designed to be effective and capable, but also affordable enough that losing some in combat is acceptable from a strategic and economic standpoint. It's the difference between chess, where losing your queen is devastating, and checkers, where pieces are valuable but replaceable. The Fury represents the first serious attempt to bring this concept from theory to reality with a jet-powered fighter-class aircraft. Anduril Industries itself is part of this new wave of defense innovation. Founded in 2017 by Palmer Luckey, the creator of Oculus Virtual Reality, the company has deliberately positioned itself as the anti-establishment defense contractor. While traditional giants like Lockheed Martin and Boeing have dominated military contracts for decades with their careful, methodical approach, Anduril operates more like a Silicon Valley startup. Move fast, embrace risk, and use cutting-edge commercial technology instead of specialized military-grade components that take forever to develop and cost a fortune. The timing of the Fury's development is no coincidence. The Russia-Ukraine conflict that began in 2022 has fundamentally changed how military analysts think about modern warfare. Ukraine has demonstrated that relatively inexpensive drones can devastate multi-million-dollar tanks and even threaten expensive naval vessels. We've watched as $10,000 quadcopters sink $40 million patrol boats. This has sent shockwaves through every military planning office on the planet. If cheap drones can dominate ground and naval warfare, what about air combat? Quick pause. What do you think? Should autonomous jets like Fury make life and death calls without humans? Tell me in the comments. The Fury's design philosophy extends far beyond just being cheap. It's built around what Anduril calls collaborative combat, or manned-unmanned teaming. Picture a veteran fighter pilot in an F-35 acting as a quarterback, with 3 or 4 Fury drones operating as the offensive line. The human pilot provides strategic decision-making, ethical oversight, and high-level tactical planning, while the autonomous Furies can fly ahead into dangerous airspace, draw enemy fire, conduct reconnaissance, or execute strike missions without risking human lives. This formation offers ridiculous advantages. The Fury drones can pull maneuvers that would cause a human pilot to black out from G-forces. They don't need life support systems, ejection seats, or the extensive safety equipment that protects humans, which means more space for fuel, weapons, and sensors. They can be stationed in distributed locations and launch rapidly, while traditional fighters require extensive runway infrastructure and maintenance facilities. The manufacturing process behind the Fury is also revolutionary. Anduril utilizes advanced composite materials and automated assembly processes that dramatically reduce production time. Traditional fighter construction involves thousands of precisely manufactured parts that must be hand-fitted by skilled technicians, a process that can take 18 to 24 months per aircraft. The Fury's modular design means major components can be produced simultaneously in different locations and assembled quickly, potentially reducing production time to just months or even weeks. From a strategic perspective, the numbers game changes everything. Instead of purchasing 20 extremely capable F-35s for $1.7 billion, a military could potentially buy 500 Furies for $1.5 billion and still have 20 F-35s calling the shots. Suddenly, adversaries don't face a small fleet of irreplaceable fighters, but a swarm of capable autonomous aircraft that can absorb losses and keep fighting. It's the military equivalent of shifting from hiring a few expensive specialists to building an entire team of skilled professionals. The Fury's development also signals a broader transformation in military procurement. For decades, developing new fighter aircraft meant 10 to 15-year development cycles, with costs spiraling as requirements changed and technology evolved. Anduril's approach embraces rapid iteration, using digital twins and simulation to test designs virtually before committing to physical production. This methodology, borrowed from commercial aerospace and tech industries, could fundamentally accelerate how quickly militaries adapt to new threats. Of course, questions remain. How will the Fury perform in actual combat conditions against peer adversaries with advanced air defense systems? Can autonomous systems really handle the split-second decisions required in air-to-air combat? What about cybersecurity vulnerabilities in a heavily networked autonomous platform? These aren't trivial concerns, but they're exactly the kinds of problems that get solved through real-world testing and deployment. The Anduril YFQ-44 Fury represents more than just a new aircraft. It's a fundamental rethinking of air power in the 21st century, where quantity, affordability, and rapid production might matter more than individual platform supremacy. Whether this approach succeeds or fails will shape military aviation for the next 50 years. And we're watching this experiment unfold in real time. The age of autonomous fighter has arrived, and the sky will never be the same. Give this video a thumbs up if you want more explainers on next-gen military tech. Share this with a friend who still thinks drones are just flying cameras.